Hey, Hungry Pixel Team here. Today, we are going to talk about violence in video games, and how our helpless children are deeply influenced by that. Just kidding. Now we have your attention. Let's talk about blood in video games, and the 2D pixel Bloodstain system developed for a world narrative experience called Netherworld. If we write about blood in video games, Mortal Kombat has to be here. Probably, it was one of the first games that started to spread blood everywhere in the scenario. Considering its 90s console technical limitations, blood looked quite good. Bloody fatality in Mortal Kombat. What an awesome fatality. If you look close to it, there are blood splashes on the floor that start their animation when the blood stream is still in the air, left of the screen. Besides, the stains disappear quite fast. There is not much to comment here. They had more important worries in that time, and Twitter did not exist, so it was difficult to be a hater. Do you remember Toffard? Hook on, T. Let's pay attention to the stain in the green frame below. Without shot, blood drops hit the ground, and a blood drop textured plane is instanced just there. Did they use a blood pool? If they did, we find it convenient. With this method, it is not possible to have infinite blood stains, so they disappear progressively. The stains are also removed when the police car hides them from the camera and hisses dramatically. Toffard, okay, Hitman 2, we have just killed our target and left some blood stains in the wall and floor. The method used here is different from the one in Toffard, and allows showing the stains in the scenario permanently. How do they do it? Hitman 2 modeling has textures that can be modified in real time, and there are previously painted bloodstain images ready to appear. When we decide to shoot anyone who deserves it, once the bullet goes through a body, the script calculates its trajectory. If there's an obstacle behind the potential corpse, it's time to determine the point where the bullet is gonna collide into the texture. Then, a blood stain will be added on that texture's exact location. Screen scales. What's the problem here? Look at the orange spheres. Textures are designed to wrap the 3D model in a natural way. But while a blood stain looks fine in a 2D texture, things change in a 3D model. As seen in the GIF above, there's the possibility, spoiler, it's gonna happen, that visual errors ruin the beauty of the scene. Beauty in terms of graphics, not all the blood and killing people stuff. Just saying. Moreover, having lots of previously painted bloodstain images does not seem to be the best way to solve that problem, at least not the most efficient one. As seen in the previous examples, most of traditional bloodstain painting methods show four main problems. 1. Visual box tendency. 2. Performance problems. Unless stains disappear, how can we fix these problems in a 2D pixel art game like Netherworld? When talking about pixel art games, it comes to our minds a kind of game you could run in a calculator. Well, we are in the 2019, not the 80s. Netherworld has scenes with high levels of illumination, shaders, e.g. grass movement, and also a varied particle system. The more these particles collide and splash the scenario with cool blood streams, the better will be. We are not psychos. Promise. Nowadays, there's a lot of stuff to consider if you want to develop a modern 2D pixel art game, and make it feel visually attractive. From now on, we will call this stuff firework resources. Here's another world scene. Comparison with firework resources and without them. Well, one would fit perfectly as a set for school play, but we prefer the bloody one. Oh, did we set school play? Let's talk about performance. The Unity forums, the Edge shows, how important is to have unoptimized blood everywhere system in our game. If we create a bloodstain every time we kill an enemy, there are tons of them and we also use firework resources in the ceiling. We will have FPS drops. As said before, Top Third made the stains disappear for the same reason. Game screenshot from Unity forum question, combining multiple sprites. Once both scenes are full of blood, we observe three differences between them. With Netherworld system, we do not create objects. Blood overdraw is reduced to 0, and the number of tries does not increase. So, you want to make a pixel art game? Yup. With massive blood levels, including coarted enemies and other kinds of bloody violence in several scenarios. Aha! And permanent blood stains. Exactly. It's time to take advantage of pixel art. We will focus on blood stains. But this system can be used for dirt or other stain materials. Pixel is the most important word in this whole section. If we applied this texture painting method on an IE model, calculations would go crazy. This method forgets about painting blood on textures by hand, and uses an algorithm that decides which pixel should and should not be dyed red in a particular radius. How does it work? Imagine you are walking down the street in a dark and cold night. Suddenly, a wild old grandma appears and tries to rob you holding a knife. Poor granny. She does not know we always carry a 9mm handgun called retirement. What should we do? Shooting her in the head. Of course. This article is about blood, not mercy. From now on, the place where granny's blood is splashed will be the point. B. First of all, we designed a simple pattern. An X pixel radius circle in a B position. This circle has a concentric rhombus inside, and several vectors go through it perpendicularly. These vectors are the traces of blood drops that will appear around the main blood stain. Unless you are colorblind, you will see the pattern is divided by three areas: a red rhombus, a green circle, and outside vectors. Each area has different staining probability values: red high, green low, outside vectors medium. In terms of quantity, we think this pattern allows us to obtain acceptable blood stains. However, we do not discard to go a little bit further and work on a more variable pattern. For example, implementing Netherworld's blood staining pattern. We have a blood stain pattern. Cool. Let's use it. All textures inside the radius will be suitable to be stained. This way we fix the traditional method problem of not staining parts from other object textures, even if they are involved in the blood splash. We love to get things complicated, so let's try to stain a surface between four textures. Blood staining different textures simultaneously. Okay, we know how to create a blood stain, and where to splash it. But blood looks different depending on the texture that has underneath, right? How do we manage blood stain colors? Well, our texture painting algorithm is working. It finds a pixel that needs to be colored, following the staining probability values explained before. Once found, it rates the texture color in that pixel and obtains four numbers, RGB. This, a value, alpha channel transparency, will be very useful to determine if that pixel belongs to the texture, a group of textures we want to paint or not. If the value is 0 or close to 0, G. Beyond texture's edges, the pixel will be ignored. RGB tridimensional color model. RGB is a color representation space through a vector with three elements: red, green, and blue. All three are quantified in levels from 0 to 2. Pixel depth -1. If we are working with 8 bits, we be talking about the standard dynamic range, st. 0 to 255. If 10 bits, it db a high dynamic range, HD 0 to 1023. One of the advantages of this tridimensional vector space is the possibility of drawing a vector from one point to another. You wanna change the color, you just have to move between the points. The original pixel color pure red vector, we want to bloodstain a pixel. This pixel has already a color, its color texture, and we want to stain it red. With our pixel texture painting system, we will draw a vector from the pixel original texture color, and we will set the pure red value to 255, 0 as the end of the vector. Let's see if it works.